So the problem reads, calculate the standard entropy changes for the following. NH2 gas plus 3H2 gas produces 2NH3 gas. This problem isn't as difficult as you might assume it would be. It's just being aware of what formula you're going to use. S in chemistry, or a capital S, stands for entropy. So you know you're going to be using an equation with S. It also says changes. Remember, delta means change, so the change in entropy of the reaction. Boom, here's your equation. If your professor's really nice, they'll give you an equation sheet, so you can just look for this. So basically, the change in entropy for a reaction is equal to the sum, the kind of weirdy, that's why I like to call it the weirdy, means sum, so the sum of the entropy of the products, and not forgetting N relates to the coefficients in your reaction. So the sum of the products minus the sum of entropy of the reactants, again N, looking at your coefficients. And that will give you your answer. So from here, you can see that I already have listed values here. These values are the standard entropy of reactants and products. So these are kind of given values that a professor or whoever's giving you the test will either supply you with, or they'll give you like an appendix and you have to just pick out these values. But in this sense, I'm already just listing them, but these are known values. There was no calculation done. Well, someone calculated it, but in this sense, they give them to you. So it's very simple. You're just going to set up your equation. So why don't we write it first without all of the numbering, without adding in all your numbers. So the change in entropy of the reaction is equal to the product. So what's our products? NH3. But don't forget, you have to consider the coefficient in this. So it's going to be 2 times entropy of NH3. Now that was really easy because we only had one product. So let's do the reactant. So again, it's products minus, so we'll put a minus. And then we need to do the sum of the reactants. So let's first start with N2. So we have no coefficient for N2, so we can leave it simply as the entropy of N2. And we're finding the sum, so you will plus it. Plus the other reactant, which is H2. This time we do have a coefficient of 3. And that will be H2. And that's how you would just simply write it. And next step is very easy. You're just going to plug in your values. So the change in entropy of the reaction is equal to 2 times NH3, 193 joules per mole. And then you're going to minus it times your reactants. So whatever N2 is. And again, I'm writing out all of the units because that's just a really good way in chemistry of keeping track of what you're calculating. So I would suggest it for everything. Plus 3, remember the coefficient, times H2, 131 joules per K per mole. And again, you sum here. So if you were to add this and then take this value and minus it minus this. So again, simple math. I don't think I really need to go over it in as much detail. You should all be able to do that. And so then your value is going to come out to negative 199 joules. Again, always include your units. I'm sure whoever is your professor really appreciates the units. You could probably get points off if you don't put it. So units, units, units. And this is your answer. If you didn't get this answer, I would consider looking at how you are plugging in this information into your calculator. Be aware of what minus, what the sum is, all of that, that is your answer.